Hello and welcome to today's video. Today we'll be talking about the Subscription Advantage Pack for AutoCAD Map 3D 2010. My name is Katie Jakes and I'm the Product Support Technical Lead for AutoCAD Map 3D. Today we're going to be showing a demonstration of the AutoCAD Map 3D 2010 Subscription Advantage Pack. It's an enhanced version of our product and it's exclusively available to our subscription customers. In the first section we'll talk about the Subscription Advantage Pack and give an overview of it. In the second section, we'll show and go over what is LiDAR data, and in the third section, we'll talk about the PointCloud tools that are specific for AutoCAD Map 3D 2010. Section 1. In this section, we'll cover what the Subscription Advantage Pack for AutoCAD Map 3D 2010 is and what it includes. Specifically, we'll talk about where it's located, how to access it, and what's included in the Subscription Advantage Pack. You can access the Subscription Advantage Pack from the Subscription Center, which is subscription.autodesk.com, or within the Communication Center inside your product. Inside AutoCAD Map 3D 2010, we have a new set of tools called the PointCloud Tools. These PointCloud features allow for large sets of PointCloud data, for example, 3D laser scanning and LiDAR data sets, to be imported and visualized within the software. It enables users to perform things like importing certain types of LiDAR data, doing visualization of the point clouds in 3D, stylizing the point data, filtering the point data, masking and deleting points, extracting the data to create surface models, snapping to points within the PointCloud tool using your standard AutoCAD software tools, exporting the surfaces, as well as exporting the point cloud layers. In addition to the PointCloud tools, we also have 3 new tutorials inside AutoCAD Map 3D 2010. The first is a set of tutorials to work with PointCloud data. The next is tutorials to work with the survey tools, including the coordinate geometry tools. And the third is to work with the annotation tools, specifically with annotation templates, styles, and text layers. In this section, we'll discuss LiDAR. We'll talk about what is LiDAR data and how LiDAR is used inside AutoCAD Map 3D 2010. LiDAR, or Light Detection and Ranging, is a remote sensing system used to collect topographic data. It's typically collected with aircraft-mounted lasers, and the scanners can collect up to 50,000 points per second. They also are capable of recording elevation measurements with a vertical precision of 15 centimeters and sometimes more. In order to capture our LiDAR, a LiDAR sensor is mounted on board some sort of aircraft, and during the flight, the LiDAR sensor pulses a narrow, high-frequency laser beam towards the Earth through a port opening in the bottom of the aircraft. The LiDAR sensor records the time difference between the emission of the laser beam and the return of the reflected laser signal to the aircraft. As the LiDAR sensor collects points, the location of the data are simultaneously recorded by a GPS sensor. And then after the flight, the data are downloaded and processed using specially designed computer software. Why use LiDAR data? It's possible to create many data products from using that single LiDAR data mission. For example, we can create things like point clouds, digital surface models, contours, land use and land cover, also intensity images. LiDAR also can be captured at night through clouds and in shadow areas. Some industry trends that we're seeing is that since 2005, the number of sensors has increased by 64% and users have increased by 100%. So LiDAR data is really hot right now. The top 3 uses we're seeing right now for LiDAR data is to work with topography or DEMs, flood risk mapping, and watershed analysis. LiDAR data is updated approximately every 2 to 5 years, although there may be more updates needed on a more frequent basis than that.
In this next section, we'll discuss what the PointCloud tools are inside AutoCAD Map 3D 2010. We'll show an overview of the tools as well as a live demonstration and talk about some best practices for working with these tools. In this next section, we're going to give you an overview of using LiDAR data inside AutoCAD Map 3D 2010. Geographic LiDAR data is most commonly available in LAS or LiDAR aerial survey format or ASCII, which is XYZ format. LAS is an industry standard file format defined by the American Society of Photogrammetry and Remote Sensing that includes a system point classification. The processed LAS file may have points classified as bare earth, high or low vegetation, building, and so on. Because the files are produced from aerial surveys, they tend to contain long swaths or strips of terrain data. The survey planes generally fly a long distance in one direction collecting data, then fly back collecting data along a parallel path. This process is often repeated multiple times, so you may need to combine these swaths and filter them by location to get the point cloud data relevant for your map. What we'll actually see today is we'll bring in some LiDAR data, we'll manage our LiDAR data, and we'll use that LiDAR data to create a point cloud data store. You can bring LiDAR data into your map in the AutoCAD Map 3D program using the PointCloud Manager, which is located in your task pane under the Tools section. In your Display Manager, click Tools and create Point Cloud Index. The Point Cloud Manager appears. You can then add files, create groups, remove groups, or remove files. We're going to go ahead and create a group first today. And in that group, we'll then add files. And we're going to take this approach because by making a group, I can bring in multiple LAS files that have been collected, so different swaths of the actual flight that happened, and manage them as one object as opposed to having to manage them as individual files. So if you've worked with raster data before, this is probably something similar to a bunch of Mr. SID files, for example, that you may want to kind of on the fly mosaic together. So we're going to go ahead and create our group. You can easily remove groups as well. And then we actually need to add an output location. So we're going to go ahead and we're going to just put it in this Point Cloud demo folder, and we're going to call this Point Cloud and save it. Now the trick about working with groups is that if you're adding multiple files inside that group, you want to make sure they all share the same coordinate system. Any type of LiDAR data that you're using should have some sort of metadata associated with it that will actually give you the coordinate system information. For today's purposes, we're not going to assign a coordinate system, but just know that you would click in here, and just like in the AutoCAD Map 3D environment, when you're working with any sort of spatial data, you can go ahead and pick what category. You know, for example, if this was the US and it was Alabama, I could pick Alabama, pick the various types of coordinate systems that exist for Alabama. Okay, so we can now right-click on that source group and add files. And we're going to go ahead and find some LAS files that we have in here, and I'm just going to pick 2 of them. I could pick the whole entire group, but just for the purposes for today's demo. And then once they've been added in, you can highlight them all, and then you're going to click this Generate Index bar, and the process may take upwards of maybe a minute or so. So I'm going to go ahead and generate that, and I'll come back when that is complete. You can see that the numbers don't really make a whole lot of sense as they keep jumping up and down, so it's not going to give you a standard 1%, 10%, 20%, etc., etc. But again, the process is no more than maybe a minute or so. Obviously, the more files you use and the larger the files are, meaning the more points that exist inside the files, this process may take longer. It also, I think, depends on what type of memory you have in your computer, processor, that sort of thing. So just be aware that because you're working with, you know, hundreds of thousands of points at one time in these files, they can be a little lengthy to process sometimes. And we should be almost done here. Okay. So once the Generate Index process has stopped, you'll see that I now have a new button called Add to Map. So what we can do now is we can go ahead and we can add that merged group, so those two LAS files, and we can bring them in to our map and use the different tools that exist for that. So what we're going to actually do is we just created what's called the PointCloud Data Store, which is that index file. It's a .isd file. And what Map3D will do is it will refer to it when it creates the point cloud objects. So we're going to go ahead and we're going to use some stylization tools in a minute. And in order to make all that work on the file, we need to have indexed it first. So the next step is to go ahead and add to map. And that was brought in. So I'm going to go ahead and close the Point Cloud Manager. And we're just going to do a zoom to extents. And you can see that we have all these points existing inside of our map. We're just going to change the background color really quick so that you guys can see. We're just going to go to straight white so that you can see the contrast a little bit more. So you can see there we have all of our points existing now. So these point clouds are standard AutoCAD drawing objects, so they're just ACDB entities. You'll see that the point clouds actually exist as a layer inside your task pane. They'll work just like any other type of GIS data that you may have connected to. For example, if you've connected to a shape file already, or an SDF file, or another raster file such as a Mr. SID or a TIFF file, those will also exist here in the list. We can easily turn them on and turn them back off. And what happens is in our different workspaces that we have now inside the 2010 product, you'll see that my screen has rearranged itself. I'm now in the tool-based ribbon workspace. And when I add that LAS file in here and create that Point Cloud Data Store, I get a new tab up here called the Point Cloud tab. And in it, I have tools such as zooming, refreshing, filtering, which we'll talk about in a moment, working with styles. I can create a new index file from here. I can also generate a surface, and then I can export the data as well. So we'll go through all these processes. Let's talk a little bit more about filtering our point cloud data. This is something we could have done when we first were generating the index file. Ways I can filter data is by types of classification. Now this classification would already have to exist inside the LAS file. So let's go ahead and we're going to, while it's highlighted here in our task pane, I went and clicked the filter point cloud data. And you can see that I have 4 options: classification, elevation, intensity, and spatial. So the classification filter tool will actually find the different classes that are already built into that file. So these are not classes I defined on the fly. This is not a default list that you see in here. I can actually say I only want to see things that are water. Apply the filter. And you'll see that I get nothing. So we can go back in and we can filter the point cloud data again. I can clear that filter. And I just did another zoom extents as a refresh. And we get all our points back. One note that if you're using point cloud drawing objects in your map that was created using AutoCAD Civil 3D 2010, you actually can't view any styling that was applied inside Civil 3D unless you download the Civil 3D 2010 Object Enabler, which you can get from the Autodesk website. And if folks have questions about that, certainly let me know and I can get you the information. So now that we've added the point cloud, we created a layer, we've done a quick filter. We could also do things like elevation. So I could type in the elevation ranges I want to display in the map. So we can go ahead and pick elevation. And again, I don't know too much about this information. So, I have to kind of know a little bit about my data. Obviously, if I'm working with a very flat area, I'm not going to have very high elevations to worry about. So I'm not going to have like, maybe 1,000-foot elevation or 1,000-meter elevation. We can get some information inside the properties dialog box. So when you right-click on, I should say left-click on an object, you can see that the properties dialog box does pop up, and it does tell me that it's just a point cloud object. Unfortunately, only one object really becomes selectable, which is the whole entire point cloud. So what it shows me here is this blue point that you're looking at right here is just the center point of that point cloud. So the individual points are not selectable, so I can't get spot elevations, as I'm kind of, zooming and panning around. Okay. So let's go back to filtering our point cloud data. We're actually going to filter by vegetations. And you'll see that some spots have been removed now that I've done the classification process. And you can see that in my command line, there's not a whole lot of commands that are really going on, or a lot of details about the commands. It's simply, I've picked the filter for the point cloud and it applied. You're not going to get much more than that. And notice that the commands map, ribbon, point cloud, filter are kind of extensive in length. So we tend not to use the commands, but certainly an option for you. I tend to go to the toolbar up here in my ribbon, or you also have the option for right-clicking and having, just in your context menu here, you have filtering point clouds, exporting, stylizing it by different levels, renaming it, doing a quick update or refresh, and then obviously creating a surface as well. Intensity is another thing I could have filtered by. So these would be, for example, like 0.25 to 2. Again, you have to define them as a range. And then spatially, you can actually click the Locate on Map button and apply a spatial filter to the point cloud. So if you know that it's a certain mountain range that you need to get the point cloud information for, basically you're masking out all the area except for the area that you've contained inside a window. Let's go ahead and create a surface at this point. So you can create raster-based surface from point cloud data in either a GeoTIFF or ESRI grid format. And then after we've created that surface, you can actually view it, theme it, analyze it, just like any other raster-based surface inside AutoCAD Map 3D. So if you're not overly familiar with working with raster-based surfaces, you can actually go into the Map 3D 2010 User's Guide that's built into this program and get more information. The Create Surface Manager will also allow us to assign multiple input files to the single surface using merge groups. So we're going to go ahead and create our surface. And just a note that it actually keeps a running tally of all the different surfaces that you've created. So even though this is a new session of map and a new drawing file inside of map, something that I did back on October 6th is actually still showing up here in my history. If I don't want those to show up, I actually have to physically select them and remove them. So I can go ahead and just remove this file. And this is the one that we're working with today. You'll see that the Generate Surface button is available. If it was grayed out, it means my surface would have already been created and it would have had a green check mark next to here like you already saw. So we'll go ahead and generate that surface. Again, this will take a minute or two, again, depending on how much data that you're processing at once. The same note, when we first brought the data into the program and created that point cloud index, that was a running list of any files that I might have worked with in a prior session of map or in a different drawing file within my same session of map. So again, if I want to kind of clear the cache that's inside of there, I have to go through and manually select things and delete them. A side note here while this is processing is that AutoCAD Map 3D will automatically resample the raster-based surfaces when you zoom in and out of map. However, the surfaces don't display well at some zoom levels, especially if it's a really small view scale. So to improve the appearance of the surface, you can resample by simply right-clicking the raster surface or the layer file over here in the map, and you have an update option here. Once I have a raster created inside of here, so I'm going to go ahead and add that to my map. And it's bringing it into just a default stylization. So again, I can right-click this raster, and I have a resample raster option here. So again, if things are starting to not regenerate properly, or you're not seeing the whole image and you think you should, go ahead and hit this resample raster, and it will bring everything back in for you. So what it does is it creates this raster file at this point that I can stylize just like any other raster that I've worked with inside the program. A couple different ways I can change the stylization. A right click here in the task pane on the actual layer gets me the context menu to show the edit style button here. I also have a style button up here. And then there's also a style editor button on the actual toolbar up in the ribbon. So we'll go ahead and use that one. Again, they all get you the same dialog box. It's just your approach of how you'd like to get there. And what it does is it just picks a default theme of green, and this would happen for any raster file that gets added in the program, not just specifically working with LiDAR data. So we can go ahead and we can retheme it. And right now it's based on height, but if I'd rather theme it based on slope, for example, and then I can, different rules are basically meaning different breakpoints. Right now they're set for equal distribution. If I'd rather do standard deviation or quantile or natural breaks, I have that option as well. And notice that I have a min and max file maximum value. These get pre-populated inside of here based on the actual data that it's reading from the surface. What I tend to do is I tend to go down to the specify a theme area, choose palette as my type, not style ramp. And then if you go into the drop-down list here, you'll actually see that there's some DEMs, there's a web safe palette if you're going to post this data up to a website. There's actually a slope palette as well, so we'll go ahead and use that. You can create labels as well, but we'll stick with this at this point. One note with raster data, you must hit this apply button here in order to make the stylization be applied to the actual raster. Very different than file-based data such as a shapefile or SDF file, where as soon as you clicked that last dialog box OK, it would be automatically applied. So now we see that we've actually applied a slope stylization to our data. The last step in the process of working with LiDAR data is to actually export the point cloud information out to a usable file format. We have three choices of file types that we can export to from within the AutoCAD Map 3D product. The first is the LAS file. We can support either versions 1.1 or 1.2. A space-delimited ASCII file, so point data with XYZ values associated with them, as well as an Autodesk SDF file format. All of these options can be found by simply going into the task pane, right-clicking on the point cloud layer, and you have the export point cloud or export as SDF options in there as well. Or up in the toolbar inside the ribbon, we have the export function and then export as SDF. A note that the SDF file created from PointCloud data can be very large and can take a long time to generate. So you do want to make sure that you have ample space in your save location for that resulting SDF file. So for today's demonstration purposes, we're actually not going to export out to SDF because it would take a rather long time. But we'll go ahead and we'll choose a different export format. You'll see that as soon as we choose the export tool, our file types are listed as either the ASCII file or an LAS file. I'll tell you that the XYZ file is probably going to be the most user-friendly in most other software programs, although the LAS files are getting more popular in most geospatial products, so those probably can be consumed rather easy as well. One note is that if you do choose an SDF file, that is a proprietary Autodesk file format. Not many other programs that I'm aware of at this time can actually read those formats, so may not be your first choice unless you're staying inside the AutoCAD Map 3D environment. So again, we'll export out to an XYZ. You're just simply going to choose a save location, give it a name, if you know the location, PointCloud, you may want to write that down inside the file name. You do a save, it exports the process for you. And once that's complete, you now have a file that you can email or do a file share with another person. I want to take this time to summarize what we've reviewed today with the Autodesk Subscription Advantage Pack demonstration for AutoCAD Map 3D 2010. Today we've covered where to find and access the Subscription Advantage Pack tools, what's included in these Advantage Pack tools for AutoCAD Map 3D 2010, what is LiDAR and how to use LiDAR and the PointCloud tools inside AutoCAD Map 3D 2010. In addition, there's a Subscription Advantage Pack available for AutoCAD 2010, which is a separate download but can be applied to the AutoCAD Map 3D 2010.